Alright, let's break down decision trees and random forests. Two of the most important tools you'll use as a data scientist. First up, decision trees. Imagine a flowchart, but for data like a game of 20 questions, except the questions help you make predictions. A decision tree is a supervised learning algorithm, and it can handle both classification and regression tasks. Here's how it works. You start at the top, called the root node. The algorithm looks at all your features and picks the best one to split the data. The goal? To create the most pure groups possible. For example, if you're predicting house prices, maybe the first split is the house bigger than 2,000 square feet? Each answer creates a new branch. This process repeats, with each branch splitting further based on other features, like number of bedrooms, year built, or location. Eventually, you reach a leaf. These are the endpoints, where the data can't be split anymore. To make a prediction, you feed in a new data point. Answer the series of yes, no questions and see where you land. For regression, you take the average value in that leaf. For classification, it's the most common class. Sounds great, right? But there's a catch. A single decision tree can overfit. If you let it grow unchecked, it'll memorize your training data, meaning it performs great on stuff it's seen, but not so great on new data. That's where ensemble methods come in. Think of it like a committee, lots of simple models working together to make a stronger prediction. Enter random forests. This is an ensemble method that builds a whole bunch of decision trees, each with a twist of randomness. Here's what makes random forests special first. Each tree is trained on a random sample of your data. This is called bootstrapping. So every tree sees a slightly different dataset. Second, when building each tree, the algorithm only considers a random subset of features at every split. This way, the trees don't all focus on the same obvious features. Once all the trees are trained, they each make a prediction. For regression, you take the average result from all the trees. For classification, it's a majority vote. The class most trees agree on wins. Why does this work so well? By combining lots of diverse, slightly off trees, the random forest avoids overfitting and gives you a much more robust, accurate model. No single tree can dominate. The randomness keeps things balanced. So, when you need a powerful, easy-to-use model that can handle all sorts of data, random forests are a go-to choice. They're intuitive, flexible, and, best of all, they just work. Alright, that's it for decision trees and random forests, two essential tools for your data science toolkit. Thanks for watching.